All right, so mammals. Okay, we're going to be talking about mammals. So let's go ahead and get started. I'm going to try not to bang on the keyboard today, but I'm not going to promise anything. So we'll talk about a little general overview. So the basic characteristics that we have of mammals, we have mammary glands, hair, or fur. They give live birth. We do have two exceptions, the platypus and the echidna, which we'll talk about a little bit later. And then they have a spinal cord and a developed nervous system. Now, they don't have to have all of these things, but they have to have at least one or two of these things to be a mammal. So, mammals have different types of digestive systems. Okay, we've got a monogastric stomach, which is a one-chambered stomach, and we have a ruminant digestive system. And all of you who are in FFA or have taken animal science probably know what a ruminant stomach is. Cow is a really good example of this. They have a four-chambered stomach, okay, and each chamber kind of does its own thing, but it's a more effective digestive system because it's able to extract 4 times as much nutrients as a monogastric animal, okay? So this ruminant digestive system, when grass goes into the rumen, then they're able to ruminate it. Now, ruminate means to basically cough it up or to basically regurgitate it and chew it again and swallow it. So it helps, that mastication actually helps with the digestion process. So not only is this mastication, this regurgitation of cud, and then the reswallowing going to help with digestion and to get the nutrients out, but also the symbiotic relationship that a ruminant has with methanogenic bacteria. So this bacteria, they kind of have this really awesome relationship where the methane gets nutrients from the food that the cow or any ruminant eats, and then the methanogenic bacteria actually help break down the food better for the animal and render the nutrients better. Which is why, if we compare a horse and a cow is going to be a much more effective organism because of its ruminant digestive system as opposed to a horse, which is a monogastric digestive system. So here are some examples of animals that are ruminants. We've got deer, so any type of deer, mule, white, roe, geese, sitka, caribou, elk, mountain goats, buffalo, bison, and most hooved herbivores, which hooved herbivores are also called ungulates, except for horses, because horses we just talked about are monogastric. So if you have your diagram, get it out. Make sure that you label this. So this is a bison stomach or any type of ruminant stomach. So the first chamber is the rumen, okay, which is the true stomach. Then we've got the reticulum, okay, then the omasum, and then the abomasum. Okay, so make sure you label these on your paper. All right, so monogastric organisms, okay? Now, horses aren't the only monogastric organisms out there. I mean, humans are monogastric. We only have a one-chambered stomach. So rabbits, horses, most carnivores and omnivores, so anything in the Ursidae, Canidae, Felidae, Mastidae, Mephididae, Vesperotillonanidae, okay? So anything that's in that category, if it's not a hooved animal, excluding a horse, it's most likely going to be a ruminant, okay? Anything else, most likely going to be a monogastric organism, okay? But just because they're monogastric does not make them herbivores. So do not associate monogastric with herbivorous animals, okay? Because that is not true. Herbivorous organisms, animals that have monogastric stomachs, but there are also omnivorous and carnivorous organisms that have monogastric stomachs. So let's talk a little bit about the reproduction and birth of mammals. So all mammals except for 2 are viviparous. So the platypus and the echidna are both oviparous and they lay eggs. This picture down here in the corner is a picture of an echidna, so after it's hatched from the egg, okay? All mammals reproduce sexually through copulation, okay? Everybody in this class should know that, okay? We're in 10th, 11th, and 12th grade, okay? But some mammals practice delayed implantation, and we talked about this in class, but I'm going to go ahead and go over it one more time. But this really means that the organism is going to wait to implant the zygote, and the zygote is a fertilized egg into the uterus only when there's a favorable environment. So it can delay the implantation of a fertilized egg. And we talked about the reasons why this is true, and most of the time it's going to be environmentally driven. So if the environment allows for the organism to have survivable offspring or viable offspring, then the zygote will implant. But if the environment is not favorable for the survival of offspring, then the zygote can be reabsorbed into the mother's body and then you can wait for a more favorable time to rebreed. Different types of mammals. We have omnivores, herbivores, carnivores. So omnivores are animals that eat plant and animal material. Okay, bears are a really good example of this. They eat berries, fish, small mammals, pretty much anything that they can get their paws on to get fat for winter, because they then go into hibernation or estivation. And this is going to protect that storage of food that they've collected in the summer and fall. And they actually have their babies in the den while they're asleep, because that gives the babies the extra protection from the elements and predators and other male bears that could come and kill them. And the mother's milk is rich in fat from all the fat storage from this spring and fall. And then when the mother bear comes out of hibernation, it's about time for the babies to start venturing out, and they're starting to eat other things other than the mother's milk. So the Mustelidae family also is an example of omnivore. Mustelidae is weasels, so black-footed ferrets, polecats, any type of weasel, ermine, mink. They eat various fish, plants, berries, so they're also omnivorous. Skunks are also omnivorous. They'll eat carrion, they'll eat small mammals if they can get them, reptiles, and also badgers are a really good example of omnivores. So carnivores, everybody in here knows what a carnivore is. It's just an organism that specifically eats the flesh of other animals. So I've got a wolf down here in the bottom and a cougar. So Canidae, Felidae, these are some examples of exclusive carnivores. Okay, and then herbivores. All herbivores are going to eat plant matter. They don't eat anything other than plant matter. They're all ungulates, and remember that ungulates are hoofed mammals. Okay, and then some gnawing animals. Beavers are kind of an example of an omnivore. They eat mainly fish, so they're actually called piscivores. But some gnawing animals like mice, shrews, voles, they are herbivorous. Okay. And most of them, these ungulates, are going to have these ruminant digestive systems, which we talked about, okay? And these ungulates are going to have protection mechanisms to protect them from predators, because if they're herbivores, they're probably going to be eaten by carnivores. So these protection mechanisms usually come in the form of antlers or horns. And antlers are made of bone, and they are shed every year. And most of the time, barring a few, if they have antlers, they're going to be specific to the males, unless they're caribou. Female caribou actually have antlers. So deer, caribou, moose, elk, these are examples of organisms that are going to have antlers. But then we also have horns, and horns are a permanent bone fixture on the animal's head that has a keratin sheath. And these sheaths are shed every year, but they're made up of keratin, so they biodegrade pretty quickly, which is why you don't ever find like a pronghorn shed or a cow horn shed, because the bone part of the horn stays on the animal's head, and the sheath actually just falls off. And keratin is the same protein that makes up hair and fingernails. Okay, so antelope, bison, musk ox, Dall sheep, mountain goats, these are all examples of animals that have horns and then shed that sheath every year. So ungulates can also have this really complex communication structure. Most of us who are hunters know that during the rutting season, we've got elk that bugle, and this helps stake out or basically inform females of the readiness to breed. And they also can communicate in grunts and whistles to indicate, hey, this is my territory. Females have calls for their young, specific to their young, so that they can tell the difference between if we take elk, for example, a mother elk can tell the difference between her baby and another elk's baby because of the call that they make, and they have this special communication. So it's like an identification call. It's almost like a name if you think about it that way. So here are some antelope up here in the corner. This is some sheath sheds, okay, and then we've got an elk here on the bottom and a shed, an antler shed. So gnawing animals, okay. like beavers, marmots, prairie dogs have unique dental structures. Okay, they have incisors, then they have this really big space called a diastema, and then they have molars. Okay, and these gnawing animals have these yellow or orange colored teeth, and the reason that they have that is because they have these iron deposits, and these iron deposits are going to make these teeth stronger because they're using these gnawing teeth to just gnaw on things all the time. So their teeth need to be a little bit harder and be protected, and so they have these iron deposits to help them keep their teeth strong. Okay, so the incisors are the two front teeth, the diastema is the space in between the teeth, the incisors and the molars. Okay, and then we have the molars, which every organism has, except for cows. So here are some examples. Here's a beaver up here in the left corner, and then we've got a yellow-bellied, no, actually I think that's a prairie dog in the bottom corner. Okay, so we're going to do a little bit of making connections here, just kind of taking a little bit of what we learned and kind of putting it to use. So nutria is an introduced organism. They came from Eurasia. So what we're going to do is talk about that in just a second. Okay, so let's resume. Nutria don't have any natural predators. They're introduced organisms, so the predators in the area have not adapted to this new organism. But they make a lot of problems on this Louisiana coastline because they don't have any predators, and so they proliferate, which means that they make lots of them. And they eat away at the native plants along the Louisiana coastline. And so they can cause a lot of devastation to natural habitats. So here's just a little bit of information about the nutria. Okay, it was introduced in the 1930s for the fur trade originally, but they're not really worth anything in the fur trade anymore. And now they've caused lots of extensive damage because of their feeding activities along the Louisiana coastline. Okay, here's our second making connections, and this is a good one. So beavers are ecosystem engineers, so they can actually engineer ecosystems just because of the dams that they build. Okay, they can make river systems more favorable to other organisms because if we put a dam in the middle of a river, it widens the river and provides more marshy habitat, which increases the biodiversity, which means the amount of species and organisms that are in an area. So as the water is backing up and creating ponding, it's going to make rivers and streams wider. More organisms are going to utilize that area, like moose, waterfowl, different types of fish, beavers themselves, and the things that come along with that. Okay, so they're actually going to create a more favorable ecosystem for a higher number of species, or have a higher biodiversity in that area. Okay, so we're going to look at some skull structures, and I want you to kind of, before I say what it is, I want you to kind of think in your head like what this skull may belong to: a carnivore, an omnivore, an herbivore, or a gnawing animal. And even if you want to kind of predict what the species is, go for it. So this first one, if you look at it, we've got some sharp teeth here on the front. We've got some really intense incisors, and then you can see the molars here in the back are also have a very pointy structure to them. Okay, so if you were to predict what this is, what do you think it would be? Okay, it's a carnivore, and this is a gray wolf skull. Okay, so let's look at this one. We can see that we've got some, again, have some intense incisors, but on the back we've got some points, but as we go back towards the back, we can see that they kind of get a little bit flatter. So what do you think that this organism is going to be? Okay, this one's an omnivore, and this is a bear. Okay, I think it's a brown bear. Okay, so let's look at this one. We can see that we've got a hard palate on the top. Okay, we've got molars in the back, but we don't have any teeth on the top. We've got teeth on the bottom. So, looking at this, what kind of skull do you think it would be? Okay, this is an herbivore because obviously it's not going to be tearing any flesh without any top incisors. Okay, and this is a horse skull. Okay, this one's probably not very hard. Looking at the skull, we've got the yellow incisors, we've got the diastema, we've got the molars in the back. Okay, so if we were to look at the skull, we would say, what type of animal is it? Okay, this is a gnawing animal, and this is a beaver skull. So let's talk really quickly about animal tracks and scat. So we learned in class that scat's basically animal poop. Okay, and both tracks and scat are really important to the wildlife biologist because we can assess the biodiversity of the area without actually even seeing the animal. Okay, so they're important in assessing not only the number of organisms but the predators that may be present and their diets. We can look at that through scat. We can also look at the age, somewhat of the ages in animal tracks. We can tell whether they're juveniles or adults. Maybe not we can't pinpoint the exact age, but we can tell how many adults are in an area and how many juveniles are in an area. Okay, so tracks and scat are really important. They are part of the data set that a wildlife biologist would need to kind of get an idea of the biodiversity of an area. So we're looking at tracks. I've got a bunch of tracks up here, so you can see kind of the differences, and I know that we looked at these in our investigation station, so I'm not going to stay on the slide very long, but you can kind of see the differences between different types of paw prints and tracks. And then again for the scat. Okay, remember that if there's hair in the scat, it's probably going to be an herbivore or an omnivore. Okay, and if it's pelleted, it's either going to be a rabbit or some type of deer. Okay, because the ungulates are way better at extracting nutrients, so their poop's going to be smaller, and it's going to be more of the nutrients are going to be extracted. Okay. So just make sure that you guys filled out your papers, and we will talk more about this in class, and you will have a test coming up soon, so make sure you study.